So what I wanted to do for probability is I wanted to create some mini videos for probability uh, to be kind of bite-sized chunks to think about probability and then allow you to kind of like ingest what it means to do probability problems, to think about probability and have develop probabilistic thinking. And the reason why I want to do that is because probability is really difficult. It oftentimes is counterintuitive. And because it's counterintuitive, it requires us to think differently. And so, what we want to do is we want to develop a really solid groundwork in what is probability, how do we go through and compute probabilities, and then so we can then build up to more complicated probability, right? Because that's one of the key foundations of this particular course in statistics. So, what I'm going to look at today is from 3.1, and this is the basics of probability. So, what we're going to look at is we're going to define two things. We're going to define what is the sample space, and we are also going to define what is probability. So, one of the key problems that I find that a lot of students have is that they start thinking about probability in terms of equating things or solving for something or doing computation without going through and actually first thinking about a problem. All right. And with probability, you must think about the problem first. So what I'm going to do is I'm going to first, let's say, for example, I want to answer the question of, right, suppose there are 30 students in the class. Okay, there are 30 students in the class. 15 of them will attend graduation. What is the probability that a member of the class will attend graduation? Now, it's pretty straightforward, okay? So what we have here, we're first going to talk about this thing called the sample space. And so what the sample space is in this case, it is a member of the class. That's the grouping that we're going to be selecting from, right? So when we think about probability, probability is always going to be a part of a whole. It's a fraction. So we're going to start out with a grouping that we're going to select from. So in this case, members of the class. Then I'm going to go in and I'm going to say, well, how many of them, okay, will attend graduation? So I'm going to split it up into attend graduation and not attend graduation. And that's how I'm going to think about the problem, okay? My sample space is the members of the class, and how the sample space is split up is it's split up into those who are going to attend graduation and those who are not going to attend graduation. Now, let's talk about this. This is not so hard. So we'll say, okay, the number that will not attend graduation, okay, is 15. Our total number, n, here is going to be 30. And so those are going to end up being really powerful, important for doing probability. We'll get to that in just a moment. Then, let's say we're doing something that's a little bit more tricky, right? Suppose I have a fair coin that I flip 3 times. What is the probability that I will get at least 2 heads? So in this case, I want to think about what the sample space is, and in this case, the sample space is going to be 3 flips of the coin. Now, in order to think about 3 flips of the coin, I'm going to have to actually go in, and what I'm going to do is I'm going to create a tree diagram in order to help me think about the sample space. So for a tree diagram, I'm going to have three what we call sets of branches, all right? Each one representing a flip of the coin. So we have the first flip, we have the second flip, and we have the third flip, okay? And for the first flip, I have two choices. One's going to be heads, the other one's going to be tails. For the second flip, I'm going to have heads and tails. For the third flip, or for the second flip, I'm also, if I flip tails now, okay, now along this branch, I'm going to have heads and tails. And then if I flip a heads and heads, I'll also have, for the third flip, I'll have heads, tails. For the third flip, heads, tails. For the third flip, heads, tails for this grouping, and then heads, tails. And then I'm just going to follow along on these branches, okay? So this branch here is heads, heads, heads. So that's three consecutive heads. Heads, heads, heads. This next branch is going to be a heads, heads, tails. The next branch, heads, tails, heads. And what you can see here is that using the tree diagram, it allows me to go through pretty systematically all the different things that could be in what's called my sample space. Heads, tails, tails. Then, now, once we're finished with all the heads, we'll go to tails. Tails, heads, heads. Okay. Tails, heads, tails. And then we have tails, tails, heads, and tails, tails, tails. Now, so in our sample space, the number of elements that we have in our sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8. The 8 different ways that I can flip 3 coins. So this one has an n equals to 8. Okay, that's all the different ways that I can go in and get elements in my sample space. Okay. And then I look at them, at least 2 heads. Now we want to remember what it means to be at least 2. At least 2 heads. In this case, I've got 1, 2, 3, 4. Nope, that's not one of them. 4. Okay, there we go. I've got 1, 2, 3, 4 of them that have at least 2 heads. So that's going to be 4 is the count there. So in generating my sample space, now what I've done is I've said, okay, here are all the different things that could be chosen from. Okay, and then I want, these are the ones that actually have the quality or characteristic that I want. Now, in order to find the probabilities, I'm going to utilize a very simple equation. The probability of an event, we'll call it event A, equals the number of desired results over the total number of results. So like, say for example, if I want to know the probability of going to graduation, the thing in here, that's my desired result. Remember, 15 people were going to go to graduation, and then there were 30 total people in the class. So this is the size of the sample space, n, and this is the frequency of the desired result. And this is going to end up equaling 0.5. Okay, so it's 30%, it's 50%. We write it as a decimal. When we talk about probabilities, we write them as decimals. We talk about them as decimals. The probability is 0.5. What about in the case of our heads? The probability now of at least 2 heads. That's going to equal 4, because that's the frequency of our desired result, the frequency of at least 2 heads, divided by 8, which is the total number of 3 flips of the coin. So consequently, that's also going to end up being 0.5. Okay? A couple of takeaways that we get here from this particular video. The first is whenever you're doing probability, this is really important. This isn't just a study skill. This is a math skill that you need to develop. All right? It's going to make life a lot easier for you, because otherwise, really, probability is pretty much impossible. you start out with thinking about the sample space. What's the grouping that I'm pulling from? Okay, and then we think about all the different things that could be in the sample space. All right. In the case of our going to graduation, you either went to graduation or not. In the case of at least two heads, we had things like, what did we have? We had three heads, two heads and a tails, another heads, tails, heads, all of these different variables that could have been in there as well. Okay. And so that allows us to then do something that's actually kind of difficult, and that's counting. Counting's kind of hard when we're doing probability. It's a lot more difficult than it looks. And so we want to be careful to develop that sample space so that we can get an accurate count, right? Once we've gotten the count, we just utilize this. This is the definition of probability, right? The probability of an event A is the number of desired results over the total number of results. And you can see why it's so important to do that counting, because then all we need to do is just plug in the values that we got from developing our sample space. All right, that concludes the mini lesson on the basics of probability.